I get a lot of questions about the whole doubling and halving a power function. One of the things that's very important to realize whenever you double, triple, halve, slice and a quarter a function, the only thing you're really talking about is affecting the input. So you're talking about if the radius of the sphere is tripled, we're talking about the input. And I'm going to show it in two separate ways, full out all the details, and then I'm going to strip down what you need to focus on the test. So when I look at this formula, if I'm tripling a radius, let's look at some different radii. So we have the radius and the volume, which is 4/3 pi r cubed. So I'm going to do my workout over here. Let's talk a radius of 1. So if I was to plug that into the 4/3 pi r cubed, if r is 1, 1 doesn't do anything. When you cube it, it's still 1. So you end up with 4/3 pi. I don't think I need to show my work for that. Now I'm going to triple the radius. So let's go over here. 4/3, this is my volume, pi times 3 cubed. As I simplify this, 3 cubed is 27. Now, of course, I can reduce with the 3 here, but I'm not going to. What I'd like to do is just write this over here, 4/3 pi times 27. Notice the original volume, when the radius is 1, is exactly the same as this right here. And what did I do? I ended up multiplying it by 27. So the only thing, if you'll notice, that's really being affected on here is the r, my input variable. In fact, I could have done the same situation. Let me start over. By ignoring the constant values. In fact, I'm just going to write them as a big C for a constant. Volume equals some constant, because 4 times pi times 3, 4 divided by 3 times pi is just a little bit larger than the value 4, like 4.2 something. But it's just a constant. It's some numbers multiplied by each other give you a value, and that value doesn't change, so I will call it a constant. Times, or we can use a k for the constant of proportionality, times r cubed. So now when I look at this, instead of writing out the constant as 4/3 pi, I'm just going to write it as k, the constant of proportionality. So I have k times r cubed. When I triple r, notice what happens. You get k times 3 cubed, which is 27k. So ignoring the actual values and simply using k for the constant of proportionality, it makes it a little bit more direct to see what's happening is only being affected inside the input variable. If I triple my input, my output is 27 times larger than it was before. I hope this makes it a little simpler for you.